Hi, everybody. Welcome to another episode of our Fossil Friday web chat. It's a collaboration between the Western Science Center and the Raymond M. Alf Museum. I'm Brittany Stoneberg. I'm the Outreach and Communications Coordinator for the Western Science Center.
Hi, I'm Gabe Santos. I'm the Collections Manager and Outreach Coordinator for the Raymond and Alf Museum of Paleontology.
And today we have Carolyn Abbott here with us. Hi, Carolyn.
What's
Hi,
up?
going pretty
Great to have you
good.
today.
Yeah, I'm really excited to chat with you guys about my research and some paleo art stuff.
I'm really excited to learn about Dicynodonts. They're
Yay.
just weird to me.
Same.
Yeah, they're pretty strange, but they're the best.
This is
Right.
exciting. So a little bit about Carolyn. She is a first-year PhD student at the University of Chicago studying evolution and paleobiology of the synapsids, or animals that include mammals and their extinct relatives and ancestors. Her love of dinosaurs started at a young age. I think that's true for a lot of us. And quickly
Mhm.
grew to a passion for all fossil life that she loves to share with everyone. When she's not doing science, Carolyn is a painter, weightlifter, lizard caretaker, and avid practicer of yoga. And I think we're going to get into some of your art today as well, right?
Yep.
Oh, nice. I'm so excited to see that.
We love paleo art in these parts.
Yeah.
Excellent.
Speaking of, we're going to try something kind of fun on Fossil Friday chats starting from now on. A lot of people have been posting some really cool paleo art online, showing us the notes they've been taking, and so we're going to start to show some of that on the stream. So kind of like a viewer of the week, kind of showing your notes. And for this week, we are actually going to show off.
With here, since I'm so close to proboscideans.
I know, right? That was some really cool stuff.
Yay.
Awesome. Yeah, well, I'm really looking forward to hearing about your paleo art as well, Carolyn. I think it's a very important part of paleontology and learning about fossils, and everybody likes looking at beautiful pictures. So I think that'll be a really cool thing to get into after we hear your talk. So, all right. So today we're going to learn about these cool animals. So, Carolyn, whenever you are ready, take it away. And if anybody has questions, as always, throw them in the chat and we will endeavor to answer them after the presentation.
Sweet. All right, let me share my screen and we'll get going. Whoops. Oh, that's not from the beginning. There we go. Yeah. So thanks for that great introduction, Brittany. Today I'm going to be talking about Dicynodonts, which are, in my opinion, one of the greatest groups of organisms that have ever walked this planet. They were the first dominant land herbivores, and in fact, your long lost cousin several times removed. So we already got a little introduction to me, but again, I'm a first year at UChicago. I did my undergrad at William & Mary studying geology, but now I'm in a biology program. And I really enjoy science because I love studying the world around me and showing others how cool it is through public talks like this. This is actually my first one online, so I'm pretty excited to be doing this for you all. So my path in paleontology, I started off with having an interest in just being outside and with dinosaurs. Then through high school, I had some opportunities to study science through my high school science fair and a internship at the USGS. At the time, I actually didn't really want to study science. I just had some really cool opportunities that showed me that that was an interesting field to become a part of. And from that, I decided I wanted to study science in undergrad in college. So I did my undergrad, as I said before, at William & Mary, where I got some really awesome research experiences in paleontology, including on-campus research, as well as being a Smithsonian intern and doing an undergrad thesis there. And now I'm at UChicago getting experience in research as well as teaching, where I'm hoping to apply that later on in a career where as a professor, I will both be doing research and teaching. So what exactly is my research? So I study the Permo-Triassic period, which was from about 299 to 201 million years ago for both of those time periods. So these are time periods. The Permian period is before any dinosaurs were on Earth, and the Triassic period is when dinosaurs are really just like starting to take off. I'm interested in periods of great change in vertebrate evolution, and these are periods where a lot was happening on land with vertebrates. I'm also interested in extinctions and recovery, and during the between the Permian and the Triassic period, the worst mass extinction in Earth's history took place. So I'm interested in what happened with vertebrates on land during that period. But most of all, those two periods are rife with animals called synapsids. And as been mentioned a couple times, I really love synapsids. I love studying synapsids. You can see here in this picture, I'm standing with an animal called Dicynodont, which is one of the earliest synapsids, and I'm just really excited about it. So what is a synapsid? Synapsids are the ancestors and relatives of mammals. So they're closer related to mammals than any other living organism. So you are a synapsid, which is pretty cool. You might have heard synapsids referred to before as mammal-like reptiles, but you should never ever call them this, and we'll get to why that is in just a second. All non-mammalian synapsids, so all synapsids that aren't mammals, are extinct, which is sad, but also really cool that I get to study them today, and we can still look at their bones to figure out how exactly these animals lived. And all of those non-mammalian synapsids were most abundant, most prolific through the Permo-Triassic period, so that interval of time from 299 to 201 million years ago. And here we have Dicynodont, which again is one of those early synapsids. It kind of looks like a dinosaur, but it's actually more related to you and me. And we have Synagnathus, which is a very mammal-like synapsid, so it's much more closely related to modern-day mammals than some of the other synapsids. And Suminia, which keep an eye on Suminia. Suminia will pop up again. So why can't you call these guys mammal-like reptiles? So for one thing, all land vertebrates, all tetrapods that lay eggs on land, which are called amniotes, have a common ancestor. So amniotes split into two groups about 310 million years ago, where reptiles and synapsids split apart from one another. So synapsids, by definition, were never reptiles. So if you follow this split, so we have synapsids here with the one opening behind their skull, and then diapsids, or reptiles, which have two skull openings. So synapsids never overlapped with reptiles. So we have to call synapsids that aren't mammals non-mammalian synapsids. And now moving back to Dicynodonts, how do they fit into synapsid evolutionary history? So Dicynodonts are one kind of a synapsid, and they're part of a group of synapsids called therapsids. And therapsids are a more derived group of synapsids that include modern day mammals. So you are a synapsid and you are also a therapsid, and Dicynodonts are also therapsids. Dicynodonts were herbivores, so they ate plants during the Permo-Triassic time period. They were highly diverse, so after modern day mammals, they were the most diverse synapsids to ever exist on Earth. And unfortunately, today they are extinct. So as I mentioned, they lived during the Permo-Triassic period, so from around 270 to 200 million years ago. All right. Key features of Dicynodonts. Dicynodonts had beaks that were keratin coated. So the same thing that makes up your hair and your fingernails covered the beaks of Dicynodonts, which is similar to a turtle or the dinosaur Triceratops. And you'll see here, so this is a picture of the skull of a little Dicynodont called Dicynodont. And so this bony part right here would have been covered with a keratin sheath for its beak. They also have these things called caniform processes, which are just a fancy name for tusks. So you'll see little Dicynodonts tusks here, pretty pointy. And otherwise, you'll notice that they don't really have teeth. So they're what we call edentulous or without teeth, aside from these really cool caniform processes. Dicynodonts also had really large cheek and jaw muscles to help them process all the plant material they're eating, similar to if you look at the jaws of a horse or a cow today, you'll notice that they have big cheek muscles too. So little Dicynodont has this big opening here, as well as this big opening here and this long groove down here on its skull. And that's where there would have been really big jaw muscles to help it process a lot of plant material. Here we have, so now I'm going to go through some of my favorite Dicynodonts, and to make it a little fun, we're going to call these Dicynodont superlatives. So we're going to go over the best and brightest of the Dicynodonts. So first off, we have Eodicynodon, which is one of the earliest Dicynodonts. And so the word Eo means early, so Eodicynodon, early Dicynodon. The skeleton of Eodicynodon has some traits that are ancestral to what we see in later Dicynodons. So they have like a very not derived morphology compared to later Dicynodonts. And so here we have a skull of Eodicynodon. This is where its eye would go. Here are those big jaw openings again. So we have the tusk here, and then where all those jaw muscles would go right here. And here's a life reconstruction of one. And they lived in South Africa during the middle part of the Permian period. One of my favorite Dicynodonts is Kemboicella, which gets the title of innovative burrower. This is kind of the employee of the month and when it comes to digging. It was also one of the smallest Dicynodonts, and it has a lot of adaptations to its skeleton that we would see in modern day burrowers. So, and its name actually means iron digger. And one thing that's great about it is it was one of the first synapsids to really become specialized for a particular role in an ecosystem. So a lot of vertebrates at this time were generalized for walking around eating plants or basic, hunting down similar size or smaller animals and being a carnivore. And this was one of the first animals that really modified its body to do one thing really well, which in Kemboicella's case was digging. Here is a CT scan that I've been working on with this specimen right here. This is an animal I've been studying in some of my PhD research. And you'll notice, so this is the upper arm bone, so like this bone on your arm, and one of the lower arm bones, so one of the arm bones down here. And you'll notice that the upper arm bone is really oddly shaped, and it has all these like really big bony processes coming off of it. So those are for really strong arm muscles so it could dig well, as well as this knob on its elbow was to help it be able to pull back a lot of dirt all at once, even though it was really tiny. Another innovative Dicynodont relative was Suminia. So if you remember Suminia from before, it's not actually a Dicynodont, but it's a close relative. And you'll notice that Suminia has these really strange hands and feet. And Suminia is thought to have been a climber. So kind of like a squirrel or a monkey today, it has these long fingers and long claws so that it can grab onto a tree and climb. So it's the first synapsid that we know of to be highly specialized for likely a climbing lifestyle. And Suminia is found in the late Permian of Europe. Next, we have another one of my favorites, Lystrosaurus. If you've heard of any Dicynodonts before, you've probably heard of this guy. And Lystrosaurus gets the title of globe-trotting extinction survivor. Lystrosaurus was one of the very few land vertebrates that survived the worst mass extinction in Earth's history. So the Permo-Triassic extinction, or again, that boundary between the Permian and Triassic periods, erased 94% of life on Earth. For context, the dinosaur extinction, about 75% of life on Earth went extinct. So this one was way worse than even the dinosaur extinction. So all of those animals were gone, but not our friend here. This guy was one of the 6% that made it through. During the Permian and Triassic periods, there were 5 to 7 species across the supercontinent Pangaea. And from the late Permian through the early Triassic, you could find Lystrosaurus in Africa, China, Russia, India, and Antarctica. So it was very widespread. And one thing you'll notice is it has this very squooshed face. So here are various examples of Lystrosaurus species, and they all look very weird. So these are all their noses that are pointing to the left here, and they have this big eye orbit. And one of my friends likes to say that they look like you took a Dicynodont and you threw it at a wall, because they have this face that's completely been squashed in. And if we look at this map over here, so this is a map of all the continents put back together in the supercontinent called Pangaea. And where you see these little icons here is where Lystosauruses are found. So they're found all over the world, and they did really good following this really bad extinction. So go Lystrosaurus. The smallest superlative goes to both Maiasaurus and Coengosaurus. So these are super little guys. If you look at this skull right here, you'll notice that this is in centimeters. So this skull was only about 4 centimeters or 2 inches long. So this was a tiny, tiny Dicynodont. Coengosaurus's skull, which is right here, was only about 4 centimeters or again, 2 inches long. And Maiasaurus's, which is right here, again, is about 2 inches long. So these are small, small guys. And here's a life reconstruction of Maiasaurus, which I think is just really, really cute. These guys were probably burrowers like Kemba. They show a lot of the same adaptations that you see in Kemba. And Maiasaurus lived during the early Triassic of South Africa and Antarctica, whereas Coengosaurus lived during the late Permian in Tanzania. So those are little guys. So of course, what's gonna have to come next is our big guy. So Lisovicea is the largest Dicynodont that we know of. It was the size of a rhino or a small elephant. So here's a really nice life reconstruction of one next to a person for scale. This animal weighed about 5 to 6 tons, so it was huge. It lived alongside the first dinosaurs, which at the time, believe it or not, the first dinosaurs are really tiny. So we think of dinosaurs normally as being ginormous, like think of like Diplodocus or T-Rex. They're absolutely enormous animals. You can imagine Lisovicea being around with little tiny dinosaurs. So these are guys called Coelophysis. They were very early dinosaurs. And here they are hanging out with Lisovicea while a couple of them graze. And this animal was found in Poland. And actually the paper that described it came out very recently. And it was from actually, so it says early Triassic there, but it's actually the late Triassic. So yeah, I was hanging out with the dinosaurs during that time period. All right, so that's what I have to say on Dicynodont. So I have some slides about paleoart, but I can either answer questions about Dicynodonts now and then move into paleoart, or yeah, I don't know what you guys think is the best course of action.
I would say go forth into paleoart, and then
Awesome.
We'll answer any questions at the end.
Sweet, sounds great. Yeah, so paleoart. Paleoart is a amalgamation of paleontology and art, as you would guess from the name. So it's taking the visuals of art and the science of paleontology and using them to help communicate science in a more effective way, and also make something beautiful out of ancient life. So as scientists, we are all communicators. Our job is to translate evidence about the world around us into information for everyone to learn. And a lot of sciences are able to use photos of the things that they're seeing, or make figures of things that they're seeing. But paleo is a little different because everything's mostly extinct. So in order to effectively communicate what we're looking at, we have to use reconstruction and illustrations to get across our science. So this photo up here is from a recent paper about a cute little dinosaur called, I think it's Calindrodromius. And so someone correct me later if I'm wrong. But so this is a skull, believe it or not, even though it just looks like a muddy rock with some streaks on it. But to a paleontologist who's trained in anatomy and preps the fossil, you can then prepare that fossil and see that there's actually an entire skull there with all these different bones. And then from that skull, you can translate that into a piece of art that everyone can understand. So whereas this just kind of looks like a rock, and you can't really see how that would be a living animal, this is something that we all can understand and see as this cute little guy that was running around during the Mesozoic. One of my favorite applications of paleo art myself as a painter is fine art. So this is a painting I really, really like from Konstantin Florov of these two Paraceratheriums. So these are giant rhinos that lived, they're extinct now, but they were the largest mammal to ever walk on Earth. So these are absolutely giant rhinos, like way taller than any elephant that's around today. And one thing you'll notice about it is rather than it being like a detailed illustration of the bones or a life reconstruction where it's just meant to describe how the animal looked, this is a very expressive painting that uses a lot of bright colors and looks to me kind of like something you'd see from Franz Marc. This is part of a piece that comes from the Blau Reiter group, or Blue Riders. So we have this really bright blue horse surrounded by all these colors, part of the Fauvis movement, or beastly color. And you can see similar qualities in this piece of paleo art. So we have an animal that lives today and an ancient animal represented in the same painting style, which is pretty cool. Another application that I really like is public outreach. So using paleo art helps increase interest in the natural sciences. It gives us an easier way to communicate new concepts. One of the reasons I really like paleobiology is that it's kind of a gateway science in a way. So everyone loves dinosaurs, and dinosaurs provide a really fun way to engage with other scientific concepts that are might be harder to get interested in by themselves. So for instance, things like evolution and climate change they seem like really big, scary topics, but if you talk about them in the context of exciting animals, it's a really good way to get the public engaged with science. And also paleo art provides a way to get more funding for research in museums. Again, communicating your science is key. And so showing people how important your work is and how cool and useful it is to everyone is a really important application of paleo art. So I have up here, this is a book called Mammoth is Mopey, which is a fun alphabet book about prehistoric animals. One of the earliest examples of public outreach at a museum was, so these kind of look like crazy animals, but these are from sculptures from the Crystal Palace in London. And so these are really, really early reconstructions of Iguanodon. These are some of the earliest reconstructions of dinosaurs. And while they look really strange, you might wonder, like, why do we keep those around if we know they're totally wrong? And the thing is, they teach us about how science was communicated in the early days of science communication, as well as how paleo art has changed and gotten better over time as we get new information. And I actually love these sculptures and the drawings that came out of this period of dinosaur science, of paleontology, so much that I actually recently got a tattoo of one of the dinosaurs here. I don't know if you guys can see it. I'll show it off better later. But yeah, I think these guys are absolutely awesome. And then finally, I don't have any of them with me actually, but I collect toy prehistory animals, so both mammals as well as dinosaurs and whatever synapsids they happen to make. I really like Safari Limited, which is this really great company. And so it's an awesome way to get kids and adults alike involved in exploring paleontology through these artistic little models. And then finally, an application of paleo art that I think is really interesting, and I got into a little bit with the first slide, is as a record of changing science. So here's another one of these really early 1800s paleontology illustrations, where you can see we have some plesiosaurs over here, and they look absolutely ridiculous. But focus on this guy right here. This is Dryptosaurus, which is a relative of T-Rex. So Dryptosaurus hanging out right there. And so during the early 1800s, this is what we thought Dryptosaurus looked like. Moving forward, this painting is really cool. This is from a painter called Charles Knight, who is one of the most influential painters in all of paleontology's history. And you can see here that these Dryptosaurus are illustrated as being very active. They're attacking each other. And this was one of the first examples of paleo art where dinosaurs were depicted as being active and ferocious rather than slow and lumbering like a lizard. Following Charles Knight's painting, we fast forward about 100 years to Eleanor Kish. She's one of my favorite painters as well, but one thing you'll notice is these are very emaciated, very starving looking dinosaurs. So this Dryptosaurus is very skinny. And what we have learned since this period of paleo art, this is kind of like the Jurassic Park era where everything looks like all monstrous and skinny, is that dinosaurs, because they were relatives of birds, a lot of them likely had feathers or filaments, especially the theropods or the meat-eating dinosaurs that were closely related to birds. They likely had, fatty tissues and deposits that made them look like real animals. So these weren't animals that were, shrunk into the bone with skin and tissue, but rather were filled out and looked much more like the animal that you'd see around today. So this is my favorite reconstruction of Dryptosaurus to date. It's by Gabriel Agueto, who's one of my favorite paleo artists. And yeah, this is, I guess, where we are today with paleo art. All right, and here's one of my first pieces of paleo art with a, I don't know, dinosaur of some kind who's in the water for some reason, chasing a little fish who's not happy about it. And you'll notice that I'm not ignoring other taxa as well. We have some invertebrates here. So even back then I was enjoying vertebrate paleontology and invertebrate paleontology. So we've got a little gastropod of some sort and a bivalve and osteichthyes, as well as vertebrata of some sort. Yeah. So yeah, I can answer questions now and show off some of my paleo art if people want it.
Awesome. Thank you for that, Carolyn. That was awesome.
Yeah, of course.
Sweet. I absolutely love that painting, and I want a copy, or that illustration. I want a copy of it now.
Well, I think my mom's watching right now, so if
I have to fight her for it.
She's got it, so she can scan that up for you if you want.
Awesome. Yes, I'm gonna add it to my wall of paleo art in my room.
Amazing.
Yes, I think pretty much everyone has some paleo art in their room. I have a Brian Eng piece in my own room. I think one of my favorites is, I'm going to mispronounce it, but one of my favorites is Duria and Antiquor, a more ancient Dorset.
Yes, I almost put that in here.
I love that watercolor.
Yeah, it's beautiful.
Alrighty, so we do have some questions. So let me get a few of those. This one is from David Moscato. Hey, David. He works over at the Gray Fossil Site, which is another partner of the Western Science Center and the Alf Museum, and we love working with you guys. So let me go ahead and pull this up.
Oh, hey, Caroline, would you mind turning off your share screen really quick?
Oh, yeah.
Thank you.
Here we go.
So David's asking, do we see Dicynodonts filling many of the same ecological roles as modern mammals?
That's a great question. So we see them filling some of them, but one of the important things to remember with Permian ecosystems is that they were widely different from the ecosystems we have today. So we see some familiar ecologies. So like, for instance, with Camboicella and Coengosaurus and Myosaurus, those little burrowing Dicynodonts, you could probably say they're similar to something like a mole or a gopher. And with Suminia, as I mentioned, it's got climbing adaptations that are similar to something like a monkey or a squirrel. But it's hard sometimes to figure out if there's like exact parallels. So Permian ecosystems were missing a lot of, I guess, like some of the more specialized niches that we would expect to see in a modern day ecosystem. So you don't see as many flying organisms in the Permian, aside from arthropods. and there weren't there wasn't the rich ecosystem of aquatic vertebrates that you see today. Yeah, there were most terrestrial niches focused on a lot more generalized ecologies, but we were starting to see some of those novelties that are in some of our favorite animals today.
Did you always start paleo loving Dicynodonts and synapsids, or did you start in dinos like a lot of people and then move on, or were you special like that?
So I would say I started with dinosaurs for sure. I did have an awareness of some other kinds of fossil life, mostly from watching the Walking With series. So there's Walking with Dinosaurs, but there's also Walking with Monsters, which is all about the Paleozoic.
I love that
and
one.
yeah, yeah, and Walking with Beasts, which is about Cenozoic mammals. Walking with Monsters was probably my introduction to synapsids, and I actually remember being really confused by them. I have this memory of seeing the animation of Dicynodont, which is another kind of small burrowing Dicynodont, and thinking it was really cute, but also just a very strange animal, and being like, how can this thing be related to mammals? But at the time, that was kind of a passing thought. And it wasn't until I did my REU, which is kind of like it's like an internship for undergraduates through the NSF. And I worked with Hans Seuss and started working on really early synapsids. And from there, it was just, I was sold. I was like, these guys are great. And yeah, rekindled that love.
That's awesome. Those documentaries helped a lot of people in like our generation and younger. I remember watching the Walking with Monsters and seeing the what's it called, the Gorgonopsid or something.
Yeah, yeah.
I thought that was so cool.
Yeah, that's another really cool therapsid. So Gorgonopsians were these carnivorous therapsids that lived around the same time as Dicynodonts. They weren't as diverse, but they're super cool because they have really large teeth that they would use to take down prey. So yeah, they're really awesome.
And I think you could make an argument that documentaries and visual media like Walking With is definitely a form of paleo art, and
oh yeah,
has definitely influenced many of our own careers. And so paleo art has this very influential ability to get people interested in this to the point where they dedicate their lives to it.
Yeah, no, I would say that was highly influential to me. And one thing I've talked about with other paleontologists before, I think Gabe and I, like Yumi and Isaac have probably chatted about this before. We are really lacking a series like that in the modern day. It would be great to see something like Walking With taken and moved to modern day ideas of paleo art. A lot of the reconstructions you see in those documentaries are still pretty accurate, but we've learned so much even within the past 20 years that would make for really cool documentaries today, I think.
Oh, absolutely.
Mm-hmm. So even though I doubt it, if there's any documentary producers listening in on this, take our advice.
Mm-hmm.
All right, here's another question about Dicynodonts. Miria Perez is asking, how are they eating their food? Considering, they have these big cheeks and everything, like how are they doing that?
That's a great question. Also, hi, Miria. Thanks for watching. So Dicynodonts, while mammals today chew up and down, so if you like chew your jaw right now and you feel like your cheeks, you'll notice that your muscles are moving like this. Dicynodonts did the opposite. So they have something that's called palinal jaw motion. So their jaw muscles would kind of hook in so that their muscles would move back and forth like this. So they would kind of grind their food using this sort of like sliding back and forth motion. And it's weird to think about. Yeah.
I do that when I have anxiety.
Yeah, me too. Yeah, and grind your teeth. Yeah.
It's so interesting to me, like the different adaptations animals have, mostly because I'm thinking about, proboscideans and how they don't replace their teeth the same way that we do. Horizontal replacement. It's like a conveyor belt. And so this thing that we think is very fixed is like, oh, how do you chew? There's lots of different ways you can chew. There's lots of different replace your teeth. It's just crazy to me that these different animals have found what works for them in a way.
Yeah, no, it's crazy. I mean, like, yeah, that's one of there's a reason why, like, you know, there's entire like careers that are dedicated to like feeding ecology, because
Mhm.
you know, if there's a way to figure out how to chew, animals will do it. And yeah.
Ooh, right. So here's another good question. Um, Diana asks, did Dicynodonts have hair or fur?
That's also a great question. Jury's still out on that one. We don't have direct evidence of hair on therapsids like we do with a lot of the feathered dinosaurs that we know of. So one of the issues there is the preservational conditions that a lot of Permo-Triassic synapsids, or like the preservational conditions that you find those fossils in. So um, one of the interesting things about paleontology is the environment an animal dies in can affect how it's preserved. And so it just so happens that a lot of Permo-Triassic environments don't preserve hair very well. So we don't have direct evidence. However, we can use something either called phylogenetic bracketing, which is a fancy term for comparing modern things that have hair that are related to synapsids with things that don't have hair, which are related to synapsids, which we don't have because there aren't any modern synapsids that don't have hair. Or we can look at other indirect evidence in the fossil record. So coprolites, which is a fun word for fossil poop from the Permian and Triassic, have been found with hair in them. We aren't sure who they're from, but likely from some kind of therapsid, although it's more likely they're coming from something that's closer related to mammals, like a cynodont, which is a very mammally kind of synapsid. However, yeah, we really don't know, and we're working with the evidence that we have, but it won't be until we find real preserved skin from these animals that we can figure out what was going on there. But great question. Thank you.
Ooh. Here's another good one. This is from Oliver. Are there any localities in the south of the United States where Dimetrodon has been found?
In the south of the United States? Yes. Yeah. So that's one of the classic places where Dimetrodon is found. So a lot of states in the Southwest, like New Mexico, Oklahoma, some of the red beds in Texas. So those are all classic places where you can find Dimetrodon. Another place where Dimetrodon has been found in the world is actually Germany. So the smallest Dimetrodon we know of is actually from Germany, but most of the ones we know of actually do come from the Southwest United States. So great question.
Do you want to go there one day to look for stuff? Or
I
have you been
would
there?
love to. I've been there for conferences and for, oddly enough, structural geology fieldwork. So my undergrad field course was to Arizona and Utah, but we weren't at the time focusing on fossils. We were focusing on learning about the history of the rocks themselves there. But yeah, I would really like to be able to go there and actually, you know, look around for early synapsids.
As someone who's done field work in New Mexico, I can highly recommend it. It is beautiful. It's
Awesome. Yeah, I would imagine so. Yeah, it was pretty hot when I was doing structural geology field work there. I was in Valley of Fire at one point. It was like 115 degrees, and I was like, you know, being from Virginia, it was like, what is this? What's going on?
115? No.
Yeah, it was so bad.
I was used to the heat when we went to our field site in New Mexico, the Western Science Center's field site. I wasn't used to the elevation. So
yeah.
I thought I was a decent hiker. I was like, I can do this. I can hike several miles and I can dig for hours. And then we went out, and the high elevation is what really killed me for the first couple of days.
I can totally relate. I have mild asthma. Like it's very mild, but I hadn't been taking one of, huh?
I said, oh dear.
Yeah, I hadn't been taking my Singular, which is like my daily like long steroid. And I had just had like pretty bad like strep and like a chest infection. And I was like, yeah, I can go to like mile above sea level and like not be on anything. Yeah. So I was fine. But I remember the first day I sort of like set off and I was like, yeah, we're doing this. And like within 10 minutes, I was like, I think I'm getting heat stroke. But
Oh
yeah,
no, the
yeah.
perils of field work.
Oh, yeah.
Take it from the paleontologist, take it slow when you're in a high temperature environment in an elevation you're not used to. Take it from us.
Yes. Yeah. Yeah. Always go with like, the minimum end of what you think you're capable of. Cause like, if you get yourself in to a remote location, you've got to get yourself out. So, safety is always more important than being like, the toughest person there.
If you hike in, you have to hike out. So,
Yeah. Yeah.
And take enough water.
Mm-hmm. Yes. Yeah. Drink water always.
Here's a nice transition into your paleo art, which I could see a little bit of in the back, and I think we're all excited to hear more about it. What's your favorite medium you work in? This is from Rob, who is the same paleo artist that we just showed some sketches from earlier today.
Awesome. Hey, Rob. Nice to meet you.
Let's show off Rob.
I just bought a palette of, I'm going to pronounce it incorrectly because I cannot remember, gouache?
Oh, gouache.
That. Mm-hmm. Gouache. So I just bought a palette of gouache, which I've worked with a little bit, but only as like a way of doing highlights when I do watercolors. And so I was like, oh, right, this will be fun. It's so hard.
Yeah.
Hey,
yeah.
Caroline.
Yeah.
Sorry, we actually lost sound for a second when I switched over.
Okay.
I pushed the wrong button. Could you repeat your answer, please?
Okay. To the paint medium thing?
Yeah, what medium do you like to use?
Okay,
Sorry.
yeah, so no worries. So I said that I started off with oil paint, and I still really like oil paint, but I like to work really quickly and work back into passages that I've painted, in over like a quick time period. So I've moved into acrylic and vinyl paint, which dry faster and are water-based, so they're less toxic, have easier cleanup, and they're also cheaper. I didn't mention that before when the sun cut out, but they're way cheaper, which is great. And then I also really like, for drawing mediums, I really, really like charcoal. It's messy, but it's really fun to move around. And it feels kind of like the paint of drawing mediums in a way. Yeah.
Nice.
Awesome.
Alrighty. Yeah, so hopefully I just started with gouache myself and I was just like, this is hard.
Yeah, it's like the evil twin or like evil, evil relative of watercolor and acrylic. It's like somewhere in between both of them and it doesn't know where it wants to be.
Oh man, yeah. I just bought a gouache set, or I just got a gouache set. I didn't buy it. Somebody, my friends gave it to me for Christmas. I was so excited to try it, but now I'm scared.
It's fun.
It's fun. Yeah. Yeah. It's just a steep learning curve.
Yeah. I'll just say, like, when I personally paint in watercolor, I can usually be like, oh, I am satisfied with this thing that I have drawn. I have not gotten there with gouache yet. Gouache is more like we're just gonna have fun with it.
It's fine. I'm not a paleo artist, so.
Yeah. Here's another good question. Are you self-taught or have you taken classes?
In art?
Yes.
Okay. So I've taken classes. So I took classes all the way through grade school, and then in undergrad, I actually intended to double major. But because I wanted to take a lot of biology classes as well as geology classes, I ended up minoring in art. So every semester, of undergrad, I took classes in life drawing or painting. None of them were paleontology focused though. So a lot of my paleo art is a mix of just sort of like amalgamating my knowledge of anatomy from science with how I think about anatomy and art and kind of trying to smoosh it together. But I think that's kind of how a lot of paleo artists work. Like they have, you know, an interest in the anatomy, and then just trying to reckon that with like the formal aspects of art, which is like the fun puzzly bit, in my opinion.
That's what I like about paleo art, because a lot of people are always like, "Oh, we need STEM, we need art," and they never like put it together. But like, there's the whole STEAM thing, and
Yeah.
definitely paleo art is where like art, science work together to create like,
Mm-hmm.
well, a beautiful picture. So
Yeah. Yeah. And it's a great way, like I mentioned earlier, it's a great way to get people engaged with science or art. Um, yeah. And I think like the act of, you know, just sort of like drawing uh, animals that you know, you can't see today, but you have to like use clues to reconstruct is just like such a fun thing that, you know, anyone with curiosity, it like you can't help but just like love, you know, either doing it or enjoying seeing it because it's just like such a fun puzzle.
Somebody in the chat mentioned Dinotopia, which I very distinctly remember.
Yes, yeah.
So yes, I think there's a lot of having that combination of art and science. I think is very important, and it's enjoyable.
Mm-hmm.
Dinotopia was fun.
oh
Yeah,
yeah,
yeah.
wasn't there like the group of people in Dinotopia that could ride like the
Yeah.
pterosaurs?
Yes.
That's
Yeah,
what I wanted to be.
yeah, yeah, the dream.
Oh man. Yeah. And with I mean, how many of us at our age and our generation, I think we're all millennials here, you know, we're inspired by Jurassic Park and these other, like we said with Walking with Dinosaurs, it's like we we've definitely made decisions about our careers and what we want to learn about based on art.
Mm-hmm, mm-hmm. Yeah, yeah, and it's like a really good way to get people, you know, involved with thinking about biology. Yeah, yeah, for those reasons, they're just like, you know, you can't help but want to know more about them after you see those really cool pieces of art.
Or any science for that matter, right? Like
Yeah, yeah.
a
Hmm.
lot of like what Brittany and I do is combine pop culture with like our cosplay for science initiative, and there's a lot of really cool ways. Ah, cool! You have the sticker.
Yeah.
Yeah. And I mean, me personally, coming from an English background, so my undergrad was in English, I like, you know, using my writing skills and whatnot. And I feel like that's made me a more well-rounded person, paleontologist, etc.
Hmm. Yeah, I mean, like books like Raptor Red and things like that, you know, along with Jurassic Park. Um, yeah, I didn't talk about writing, but like paleo fiction, I guess, you know.
That
Mhm.
book is in the museum bookshelf, and I've been like people have been telling me to grab it and read it, but I have yet to
Hmm.
start it.
I've read bits and pieces of it, like full disclosure, have not read the whole thing, but yeah, that's another one I need to get to.
And I did love the shout out that you gave to Mammoth is Mopey.
Yes,
Really
yeah,
great children's book.
yeah, it's so cute.
Um, here's a lovely question. This is from Alexa, who is 7. Who's your favorite Dicynodont?
Awesome. Hey Alexa, my favorite Dicynodont is probably either Myosaurus or Diectodon, because I think they're really small. Well, I don't think they're really small. They are really small, and I think they're super, super cute. And I just like the idea of this cute, tiny little burrowing animal. And definitely, if I had a fossil animal for a pet, I think it would be really fun to have a Myosaurus.
I also share your affections for things that are smaller than they're supposed to be,
Yes, yeah,
like
so good.
Channel Island mammoths. And
Yeah,
I study horses, and I'm just like, yes, small horses. So
yes. Yeah, so adorable. I have
I
a
like derpy looking things.
yes. Oh, speaking of which, I have a blue-tongued lizard, which you if you haven't seen one of those before, they're a really cool animal. And they're a kind of skink, which if there's anyone in the who's listening right now who lives on the East Coast, you've probably seen like the little blue-tailed ones around. But these guys they're big for a skink. They're about this long, but they're so silly because they have like really tiny arms. So on that long body, their arms are like that long. So yeah, they're kind of like if you went to the other side of the vertebrate tree over to reptiles and looked for something similar to a small Dicynodont, blue-tongued lizards are what you'd find.
And Carolyn, here's another one. This is from Shauna. Do you know what caused the Permian Triassic extinction?
Ooh, that's a great question. So that's another big mystery. We think we have we have several ideas as to what happened. So one thing that was happening during that time period is Pangea was rifting, and so rifting is a geology term for breaking apart. So the continents today are all separated, and the Atlantic Ocean is in the middle of all of them. And when Pangea was together, the Atlantic Ocean hadn't opened up yet. So as the crust was breaking apart and the continents were separating, you had really intense volcanism. So volcanoes are going crazy. There were these things called flood volcanoes. So if you think of a volcano today, it's just like a mountain that spews out lava. These were literal cracks in the earth where lava was coming out of. And so one idea was that the volcanism was just so bad, they were spewing essentially greenhouse gases into the atmosphere, which caused really severe global warming and acidified the oceans. In many ways different from, but you can kind of draw some parallels to what's happening today with that theory for how it came about. But essentially the hothouse conditions got so bad that a lot of animals, plants, fungi, all across the tree of life were really devastated from both the heat and like chemical fallout of that. Another idea that kind of follows that is that there was increased turnover in the oceans due to gas interactions. I'm not a geochemist, so I can't go into exactly what was happening with that, but some sort of a cascading reaction of chemical reactions either in the ocean or on land caused that large die-off. Yeah, so it's a good cautionary tale for what we're going through today with our climate.
Among other things, right?
Yeah.
No big deal.
Yeah.
Alrighty. Trying to see if there's any other questions. There has been some great paleo art discussion in the chat.
Oh,
I saw one that I had. There was one from one of our previous speakers, Con. Hi, Con.
Oh, yay.
She says, "Hi, Caroline. What is the function of the Dimetrodon sail?"
Oh, goodness. Another brain teaser. Yeah, Con, that is a great question. So there are two main ideas with that right now. So one would either be for thermoregulation, so regulating heat in the animal's body. So with an early synapsid like Dimetrodon, they probably weren't endothermic or warm-blooded yet. So having a structure like that on your back might be a good way to maintain heat. And another really good idea is that it was a display structure. So a way to either show off to other Dimetrodon or maybe other animals in the ecosystem. Again, having something big and frilly like that on your back is a great way to show off or say something to other animals. And a third one, this is a complete joke one, but one that my dad and I joke about is that they used to stand on rafts and use it to cross Permian seas. So,
all right, so we need to
Nice.
draw that. Just throwing this out into the universe, somebody needs to draw that.
Yeah, I did for a birthday card for him one year.
Oh, nice.
Yeah.
Can we animate it to the song from Moana? like we know the way.
Yes, please. Yeah, I would love that.
What I particularly love is the um, speculative nature of a lot of paleo art, since you can't know exactly how things looked millions of years ago. So I
Hmm.
think, like how you mentioned, maybe the sail is a display, and I think a lot of times when we see Dimetrodon in paleo art, it can be kind of gray and staid. It's all one color. I would love to see some reconstructions of just completely wild colors and patterns on that sail. That would be amazing.
Yeah, I've actually seen there was one, there's a great Facebook group called Paleo Artists if anyone's interested. Um, and there, I'm trying to remember who did it, but someone recently did like this gorgeous, very colorful Dimetrodon. I'll try to send it your guys' way later, but yeah, that I saw that and I was like, oh my gosh, that would be the coolest. Cause yeah, it's like, so many, it's like where is the balance between like beautiful coloration, like really bright colors and um, having more realistic colors. And I think a lot of times people think that realistic means drab, but if you look at, modern day animals, like even things like, like if you look at like a pond turtle, red-eared sliders have like this beautiful red stripe, this little accent, like they have a cat eye on the back of their head. You'll see like I have this little downy woodpecker that likes to hang out outside my window. He's got a little red cap on. Mammals do crazy things with like stripes and spots and all and their coloring. So yeah, it's great to draw from life and speculation when doing paleo art.
Here's a question. This is from Logan, who is 11. What caused the Cambrian explosion?
Oh, wow, that's a great question. Hi, Logan. So you're going to be stumping me there because I actually don't work on the Cambrian explosion. But a couple ideas that I learned from my paleontology classes um, include nutrient availability. So there might have been some sort of an event that caused new resources to be available for animals, which allowed them to take on new forms since they had more energy available to them. Kind of going along with that, the advent of competition between animals might have allowed for that to happen. So if you think of today, when you look at animals that have either tools for predating or protecting themselves, so you see things like shells and spines on animals that are prey items, horns, things like that. And then on predators, you see big teeth, sharp claws. And so if we look at the Cambrian explosion, you see the advent of like really cool predators like, I'm trying to think like, I guess Anomalocaris was a predator, right?
It was a predator.
Yeah, yeah. So yeah, predators like Anomalocaris, Ohobinia, other arthropods. So competition between organisms might have been part of that. But if you're interested in learning more about the Cambrian explosion, I know some people who work on it a lot, and they would definitely be able to give you some better and more thorough answers on that one.
I think there's a great Eons episode where they go over that, if I recall correctly.
You're right, yeah.
Yeah.
I should rewatch that one.
Yeah, so PBS Eons is good for an overview of the Cambrian explosion. And then this is just, can you just go over, this is from Adriana, who is also quite young. Can you just go over one more time how Dicynodonts eat? They missed that part of it earlier.
Sure, yeah. So Dicynodonts eat with something that's called palinal motion, where they move their jaw back and forth. So if you think of like when you chew, so you chew up and down. So like if you're eating an apple, you don't move your jaw back and forth. You like go yum, 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 and like move your jaw up and down. But a Dicynodont wouldn't be able to do that. They would have to, if you think of like this is the top part of the head and this is the bottom part of the head, rather than going like this to eat, they would have to go like this. And the reason they had to do that was because of how their muscles were attached to their head. So your muscles are attached up and down, and theirs would have been attached more like back and forth, if that makes sense. Yeah.
Sorry, I'm
like Yeah, my chewing and my hands.
No,
Yeah.
I'm laughing at Gabe hurting himself.
Oh no, Gabe, what'd you do?
I've been like clenching my jaw because I've been like a little stressed out with everything happening, like subconsciously, and so I've
Yeah.
hurt myself. So if I move my jaw in the wrong way, it hurts.
Oh
It's the
no.
stupidest thing.
So
You
don't.
need to try some palatal motion instead of chewing
Yeah,
up and
yeah,
down.
yeah.
Awesome.
Really quick before we end, Caroline, can we see your tattoo, please?
Oh yes, yeah. So I got a new tattoo before the pandemic. Here, I'll stand up. But so it's a crazy animal called Megalosaurus. And so for those of you that know paleo, you might be looking at that and go, that's not Megalosaurus. That animal is standing on 4 legs. So Megalosaurus was an animal that looked a lot like T-Rex. It was a dinosaur that stood on 2 legs and ate meat. But the first time someone tried to draw the animal, they drew this crazy thing, which I think is one of the coolest looking drawings that I've ever seen in paleontology, even though it was like drawn in 1850 or something. And I love early paleo art so much that I wanted to get a tattoo of the one that I thought was the craziest. Although early Dicynodont drawings are pretty crazy too. So,
Caroline,
yeah.
I think your mom is on the chat and she wants
Oh,
to see your tattoo too.
Yeah, that's funny. I was talking to them yesterday and totally forgot to be like, oh yeah, a couple months ago. Yeah.
Well, you saw it here live, folks.
Yeah. They know on my other one. It's fine.
Oh, Rob has a great piece of advice for chewing like a Dimetrodon. Don't try this at home.
Yeah.
Yeah.
Yeah,
Nope.
that is very good advice.
Brittany, you have a
Awesome.
paleo tattoo, right?
I do. So I have several, but because I'm wearing longer sleeves, I'm only going to show you one. I have a ichthyosaur on my forearm. So this is actually pulled from a geology textbook, which I have right here. This is a geology textbook from the 1800s, and I bought it at a flea market, and I found this beautiful engraving of a ichthyosaur, and so immediately I was like, I have to have that.
That's awesome.
I don't study them, but just for historical reasons, I just love ichthyosaurs, plesiosaurs, and those kinds of animals. So I'm very excited to get a tattoo, and I'm sure eventually I'll get a matching plesiosaur.
Nice.
Amazing.
Yeah, and tattooing is a different kind of paleo art as well.
Mm-hmm.
It's all forms
Yeah.
of expression. I actually
Yeah,
don't
I feel
have
like
any
if you
paleo
go to a
tattoos yet.
Not yet.
Oh, you don't?
No, I have this one. Let's see if I can get it to show. It's so bright in my
Ooh.
room right now. This is a traditional Filipino tattoo. I had it done
Very
with the
cool.
hammer way, like traditionally, as like
That's so cool.
like a way for me to connect to my culture. And I have another tattoo that's it's kind of basic a little bit. It looks like a butterfly with Japanese kanji next to it, but it's actually Mothra and it says kaiju next to it. So it's a very
cool.
special tattoo that I got with my best friend, who we'll meet later today.
That's awesome.
And I think this is also from your mom. Will you be showing us your painting?
Oh, sure. Yeah, I can show my painting. It's actually right behind me. Or here. It'll be easier if I bring it up. 1 second, take my headphone out.
Maybe I should get a paleo tattoo, Brittany.
So I can't hear right now because I have let me try to get this in the frame because I don't have headphones on, or actually I can get one in. There we go. So this is a painting I've been working on for a while now. I actually started it my last year of undergrad, so last spring, but I haven't had the studio space to finish it until now. I actually just got my studio in Chicago set up. So hopefully within the next month or so, I will get this done. But this is a scene I made of a late Permian forest. So we've got Alocephalodon, which is a large Dicynodont, probably the size of like a small hippo or a cow. And then a Gorgonopsian, so those really big toothed carnivores called, it's not Inostrancevia. Oops, oh my goodness.
Don't ruin it,
Sorry.
Caroline.
Huh?
Be careful, don't break it.
I know. It's like trying to wrangle everything. Lycenops, there we go. Memory back. But so Lycenops and Allocephalodon are found in a similar area, a similar preservational, preservational conditions and like similar deposits. And here they're squaring off. So we've got a pack of these Gorgonopsians attacking the Dicynodonts. And my inspiration for it was actually seeing some really cool wildlife photography of lions and water buffalo. So here, I'll put this down so I can talk. But so I saw wildlife photography of lions mobbing water buffalo, and I was like, oh, wouldn't it be cool if like Gorgonopsians attacked Dicynodonts in a similar way? And so, kind of worked on it from there.
That's beautiful.
Thank
Can't
you.
wait to see the finished piece.
Yeah. Yeah, me too, honestly. It's been too long since I last worked on it. Almost a year.
Oh,
Yeah,
wow.
it's another thing about art. Sometimes you like have to put it down and pick it back up, but I've been doing like small things in digital work since then.
Nice.
Yeah.
Awesome. Right. Well, thank you so much, Carolyn. We really enjoyed this talk. I love that it was a blend of science and art, so we can kind of show a different side of the lives of some scientists. So thank you, everyone, for joining us. We'll be back at 3 p.m. And again, if you, this is a collaboration between the Western Science Center in Hemet, California, and the Raymond M. Alf Museum in Claremont. If you would like to support either museum in our endeavors and our programs, do not feel obligated, but we will have information after this is over where you can support our programs if you feel so inclined. So join us again at 3 p.m. and we will see you then.
Thank you so much for having me. Bye.